Okay, so some of you got started on the warm-up on our test day, and some of you did not. So hopefully you are trying it for extra practice. All right, classifying by degree in terms. We can describe polynomials by the degree and by how many terms they have. Remember, terms are going to be the values that are separated by your addition and subtraction signs. And degree is your exponent. Okay, degree, look for the highest power of the variable. Terms, look for plus or minus signs that separate the terms. Okay, so if you have, we'll just go down our degrees first. A degree of 0 is a constant. X to the 0 power, remember anything to 0 power is 1. If I have x to the first power, that's where I'm going to have a linear shape to my graph, a straight line. If I have x to the second power, let's think about picture that looks like. That is our quadratic. If I have an x to the third power, that's where I add a new curve and I end up with a cubic function. And x to the fourth is where I add another curve, and that is what we're going to call a quartic function. Think about 4 quarters in a dollar. All right. If I have my number of terms, anytime I just have a single term, that is a monomial. Think about mono, representing 1. If I have 2 terms, that's a binomial. Think about a bicycle with bi. And then a trinomial. Think about a tricycle with 3 wheels. Anything more than that, we just call that a polynomial. So a single term can be anything. It doesn't have to be just a constant. If it's linear, x squared, or if it's a binomial, it can have 2 terms. 3 terms is what we see most often when we talk about quadratic trinomials. And if I have 4 or more, that's going to give us more terms. All right, classifying by number and degree. This is 1 term. These are the tricky ones that get you because you think you see that 8, but there's no plus or minus signs. So this is a quartic monomial. When we look at this, it's not in standard form. This is our highest power, which is going to make it a cubic. And I see 1, 2, 3 terms. Cubic trinomial. 5, 3, 2, 1. We have a to the 5th power. And maybe we need to add this in. To the 5th power is going to be quintic. Quartic and quintic. Quintuplets are 5. So a quintic polynomial, because I have more than my 3 terms. 1, 2, 3, 4, 5 terms. All right, so let's describe a couple polynomials here. All right, so I see a 5th power, so it's a quintic 1, 2, 3, 4 polynomial, which means it's to the 5th degrees, which means it has 5 possible zeros that are the result of 4 terms. Because it's an odd number, as x approaches negative infinity, and remember this is positive, So my graph is going to look like this. 1, 2, 3, 4. I have my 1, 2, 3, 4 turns, and my potential of 1, 2, 3, 4, 5 solutions. But as x approaches negative infinity, so do my y's. As x approaches positive infinity, so do my y's. All right, let's take a look at this next one. Here I have a reflection, so I know that this graph is going to look like that. It is a quartic binomial. It is to the 4th degree with only 1, 2 terms. 4th degree, 4 possible zeros, and 3 terms. Here's one turnaround, another turnaround. There's my third turnaround. Both of these end behaviors are to negative infinity because of that negative sign. All right, let's check out the back. I love these sketching ones. Polynomial which just has a degree of 3 and 1 real zero that has a positive value. So my real zero is positive. I'm going to put that there. As x approaches negative infinity, it doesn't tell me. That's a question mark. Okay. A degree of 3 means it's going to come with 1 real zero. So I have, it can come up here and there you go. A polynomial that has a degree of 2 with 1 real double root that's a positive value. Here's my double root where it bounces. It has a degree of 2, so it's just going to have 1 turn. And there's my positive double root. All right, let's check out this one. A 3rd degree function, 1 real root and 2 non-real roots, and a leading coefficient greater than 1, which means that this is going to be a stretch, so it's going to be a tall, skinny graph. 1 real root. It doesn't tell me if it's positive or negative, so it doesn't matter. 2 non-real roots, so let's make it a very tall, skinny, and here's my 1 real root. Okay, a 3rd degree function, 4 real roots, including 1 root with a multiplicity of 2, and as x approaches positive infinity, so does y, which means that my graph is going to be positive. So 4 real roots, 1, 2, 3, and one of them is the double root. And it doesn't matter which one you pick as the double root. So I'm going to come down. There's my double root. And so here's my double root. It's a positive 4th degree function. All right, a polynomial that has a degree of 3, 1 distinct 0, that means it's unique, just 1 where it crosses the axis, and 1 0 that's a double root. So it doesn't say anything about positive, negative. We'll give you one of each. And if it's got 1 double root and then 1 real root. Now there's lots of different ways you could draw that. So if you're confused by this and you're like, well, how'd she know? If it doesn't give me specifics, I can guess. If I wanted to have this be this way and make this one my double root, I could have. Instead, I made this one my double root. So think about the difference between a double root and a non-real root. That's where it doesn't touch the axis at all. All right, a polynomial that has a degree of 2, so it's quadratic. It has 2 real zeros, and because I see my end behavior as x approaches negative infinity, y approaches negative infinity, that means that this is a negative. Degree of 2, 2 real zeros. So it doesn't say anything about positive or negative. So I can go ahead and draw this one like that. And I know it's a negative quadratic. All right, good job.